So your water heater just died. Maybe you woke up to a cold shower. Or worse, you walked into the garage and found a puddle spreading across the floor. You call a plumber, he takes one look and says the tank is shot, rusted through from the inside out. $1,200 minimum to get a new one installed, maybe more. And here's the part that really stings. That heater was only 7 or 8 years old. It should have lasted 15, maybe even 20. So what happened? That's exactly what I'm going to break down for you today. I'm going to show you why 90% of water heaters die years before they should, what's actually going on inside that tank that nobody tells you about, and the dirt cheap maintenance that can add 5 to 10 extra years of life. And if you stick around to the end, I'll show you an upgrade that essentially makes your tank corrosion-proof for under $100. Let's get into it. Here's the thing. Your water heater is probably the most neglected appliance in your house. Not because you're lazy, but because nobody ever told you it needed maintenance in the first place. And once you understand what's really going on inside that tank, you're going to wonder why this isn't common knowledge. So let's start with why most water heaters are set up to fail from day one. If your home was built by a production builder, and I'm talking about the big names that put up dozens or hundreds of homes in a development, your water heater was chosen for one reason and one reason only. Price. Not quality, not longevity, not efficiency. Price. Builders are working on tight margins, and every appliance, every fixture, every component in your house was selected to hit a number on a spreadsheet. Your water heater is no different. What you end up with is what the industry calls builder grade, and that term should honestly come with a warning label. Here's what builder grade actually means in real terms. First, you're getting the thinnest tank walls the manufacturer offers. Thinner steel means less material, which means a cheaper unit. But it also means less resistance to corrosion over time. Second, you're getting minimal insulation around the tank. That means the heater works harder to maintain temperature, which drives up your energy bill and puts more wear on the components. Third, and this is the big one, you're typically getting a single sacrificial anode rod. I'll explain exactly what that is in a minute. But for now, just know that a single rod in a 40 or 50-gallon tank is the bare minimum protection against internal corrosion. Higher-end heaters come with 2 rods, sometimes even a powered anode. Builder grade gets 1, and it's usually the shortest, cheapest one available. On top of all that, the warranty tells you everything you need to know. Builder grade heaters usually come with a 6-year prorated warranty. The manufacturer is basically telling you they expect the tank to start failing around that time. Compare that to a mid-range or commercial-grade unit with a 10 or 12-year warranty, and you can see exactly where the corners were cut. The builder saves maybe $150 per house, and you get stuck replacing a water heater a decade early. That's the builder-grade trap. Now let's talk about the single most important component inside your water heater that you've probably never heard of. The sacrificial anode rod. This is the part that determines whether your tank lasts 8 years or 20. And I'd bet 90% of homeowners have no idea it even exists. Here's how it works. Your water heater tank is made of steel, and steel rusts when it's exposed to water. To protect the inside of the tank, manufacturers line it with a thin layer of glass, sometimes called a porcelain or vitreous enamel lining. But here's the problem. That glass lining isn't perfect. During manufacturing and over years of heating cycles, tiny cracks and pinholes develop in the lining. Anywhere bare steel is exposed to water, corrosion starts. That's where the anode rod comes in. It's a long metal rod, usually 3/4 of an inch in diameter and anywhere from 30 to 44 inches long, suspended from the top of the tank down into the water. Most residential anode rods are made of magnesium, though some are aluminum or aluminum-zinc alloy. The rod works through a process called galvanic corrosion. Because magnesium is more reactive than steel, the water attacks the rod instead of the tank. The rod literally sacrifices itself to protect your tank. That's why they call it a sacrificial anode. When the rod is new, it's a solid bar of metal about 3/4 of an inch thick. Over time, it corrodes and gets eaten away. After a few years, depending on your water quality, it starts looking like a skinny, pitted, crumbling wire. And once roughly 6 inches or more of bare core wire is exposed with most of the magnesium or aluminum gone, that rod is spent. It's done protecting your tank. From that point on, the water starts attacking the steel, rust forms on the inside, and your tank is on borrowed time. Most homeowners never check the rod, never replace it, and then wonder why their water heater died at year 7. A replacement anode rod costs between $20 and $40. A new water heater installed runs $1,200 to $2,500. That math is hard to ignore. Now, if this kind of practical plumbing knowledge is something you want more of, I have written a guide called 50 Easy Plumbing Fixes that will save you $10,000. It is packed with repairs you can do yourself this weekend without calling a plumber. Scan the QR code right now or check the first link below. All right, let us continue. Before you touch anything on your water heater, we need to talk about shutting it down safely. This is not the step to skip or rush through. You're dealing with water that can be anywhere from 120 to 140 degrees Fahrenheit. And if you have a gas heater, you've got a live gas line involved. So let's do this right. If you have a gas water heater, turn the gas control valve to the pilot position or to off. Do not disconnect the gas line. Do not touch the gas supply fitting. Do not mess with the venting. I want to be very clear about this. Any work involving the gas line, the gas control valve itself, or the vent pipe and draft hood should be handled by a licensed professional. That's not me being overly cautious. That's a hard safety boundary that protects you and your family. What we're doing today, inspecting the anode rod, flushing sediment, checking the relief valve, none of that requires touching the gas side of things. If you have an electric water heater, go to your breaker panel and turn off the breaker for the water heater. It's usually a dedicated 30-amp double pole breaker. Confirm it's off. I've gotten into the habit of putting a piece of tape over the breaker so nobody accidentally flips it back on while I'm working. Now, with the gas on pilot or the breaker off, give the water time to cool down. I'd recommend waiting at least 2 hours, or better yet, do this first thing in the morning before anyone's used hot water, but after the heater has been off overnight. Once the water is cooled, go to any hot water faucet in the house and open it. Then pull the lever on your temperature and pressure relief valve. That's the brass valve on the side, or top of the tank, with the discharge pipe running down toward the floor. Lift the lever for about 5 seconds and let it snap back. This relieves pressure inside the tank. You should see a small amount of water come out of the discharge pipe. If nothing comes out, or if it won't stop dripping after you release the lever, that valve needs to be replaced. But that's a separate job. For now, you've depressurized the tank, and we're ready to get to work. All right, let's inspect that anode rod. On most water heaters, the anode rod is screwed into the top of the tank. Look at the top of your heater, and you'll see a hex head fitting, usually 1 1/16 inch. On some models, the anode is hidden underneath the sheet metal top cover, and on others, the rod is integrated into the hot water outlet nipple. Check your owner's manual if you're not sure which style you have. Here's what you need: a 1 1/16 inch socket, a 1/2 inch drive ratchet with a breaker bar or a long cheater pipe for leverage, and some thread sealant tape. That's it. This is a $20 tool investment if you don't already have the socket. Now, before you try to loosen that rod, here's a tip from experience. You need to brace the tank. These rods can be torqued in there pretty tight, especially if they've never been removed. If your heater is sitting on the floor, have someone hold the tank or wedge it against a wall so it doesn't spin. If it's strapped to the wall with earthquake straps, you're already good. Put your socket on the hex fitting, get your breaker bar on there, and turn counterclockwise. It might take some real effort on the first break. Once it loosens, unscrew it by hand. The rod is going to be anywhere from 30 to 44 inches long, so make sure you have enough clearance above the tank to pull it straight out. If you're in a tight space, like a closet or under low ceiling joists, they make flexible or segmented anode rods that bend as you pull them out. Those work great for tight installations. Pull that rod out and take a good look at it. If it still has most of its metal and looks roughly like a solid rod with some surface pitting, it's still got life left. Put it back in, snug it down, and check again in a couple of years. But if you see 6 inches or more of bare steel core wire exposed, or the rod is crumbling and falling apart in chunks, it's done. Replace it. A new magnesium rod is great for most water conditions. If you have hard water or you're getting a sulfur or rotten egg smell, go with an aluminum zinc alloy rod instead. Thread the new rod in, hand tight first, then snug it down about another half turn with your ratchet. Don't go crazy on the torque. You can crack the fitting in the tank if you overdo it. With the anode rod handled, let's deal with the other tank killer. Sediment. If you've got municipal water, and especially if you have hard water, minerals like calcium and magnesium along with fine sand and grit settle out of the water and collect at the bottom of your tank. Over time, this layer of sediment builds up. On a gas water heater, the burner sits directly underneath the tank. That layer of sediment acts like an insulator between the flame and the water. The burner has to work harder and run longer. The bottom of the tank overheats, and those extreme temperatures crack the glass lining from the inside. Once the lining cracks, bare steel is exposed and corrosion takes off. That popping or rumbling sound you sometimes hear from your water heater. That's steam bubbles trapped under the sediment layer. It's literally telling you there's a problem. Here's how to flush it. Connect a standard garden hose to the drain valve at the bottom of the tank. Run the hose to a floor drain outside or into a bucket. The drain valve is a standard hose bib, just like an outdoor spigot. Open the valve by turning it counterclockwise. Let the water flow until it runs clear. When you first open it, you'll probably see rusty, dirty, sandy water. That's the sediment coming out. Keep it flowing until the water looks clean, usually about 3 to 5 minutes worth of flow. If the water won't come out or it's barely trickling, the drain valve might be clogged with sediment. Close the valve, remove the hose, and carefully poke a flathead screwdriver into the opening to break up the clog. Reattach the hose and try again. For a really neglected tank, you might need to open the cold water supply briefly while the drain valve is open to stir up the sediment and flush it more aggressively. This is called a full flush versus a partial flush. How often should you do this? Once a year is the standard recommendation, and I agree with it. If you have particularly hard water, every 6 months is even better. This costs you nothing but 15 minutes of your time, and it makes a real difference in how long your tank lasts and how efficiently it heats. While you're at it, take a second to look at your expansion tank if you have one. It's a small tank, usually about the size of a bowling ball, connected to the cold water line above or near the water heater. Press the Schrader valve on top. It looks like a tire valve. If water comes out instead of air, the bladder inside has failed and the tank needs to be replaced. A functioning expansion tank should feel light on top and heavy on the bottom. If the whole thing feels uniformly heavy, it's waterlogged. Now let's get everything back online. Close the drain valve and make sure it's snug. Remove the garden hose. If you opened a hot water faucet inside the house, leave it open. Turn the cold water supply back on and let the tank fill. You'll know it's full when water starts flowing steadily out of that open faucet inside the house. Once you've got a steady stream with no air sputtering, close the faucet. check around the anode rod fitting for any drips. If you see a small weep, snug it another quarter turn. Check around the drain valve too. For gas heaters, turn the gas control valve back to your desired setting, usually the mark between 120 and 130 degrees. Follow the lighting instructions on the label. For electric heaters, flip the breaker back on. Give it about 30 to 45 minutes to start heating, and then check a hot water faucet to confirm you've got hot water coming through. You're back in business. Let's go over some issues you might run into and how to deal with them. First, rotten egg smell in the hot water. This is almost always caused by bacteria reacting with the magnesium anode rod, especially in well water systems. The fix is to swap the magnesium rod for an aluminum zinc alloy rod. That usually kills the smell within a few days. If it persists, a powered anode is your best bet, and I'll cover that in the bonus tip. Second, the anode rod won't budge. This happens a lot on heaters that have never been serviced. Hit the hex fitting with penetrating oil and let it sit for 20 minutes. Use a breaker bar with a cheater pipe for more leverage. If it still won't move, you can use a 1/2-inch impact wrench. Just make sure the tank is braced so it doesn't twist off the plumbing connections. Third, rusty or discolored water after flushing. This is normal for the first few minutes. Run the hot side of several faucets throughout the house until the water clears. If it stays rusty after 5 to 10 minutes of flushing, the tank lining may already be compromised and you may be looking at replacement rather than repair. Fourth, the drain valve drips after you close it. This usually means sediment is caught in the seat. Open and close it a few times quickly to flush it clear. If it keeps dripping, you can cap the hose bib fitting with a brass cap and some thread tape as a temporary fix, but plan on replacing the valve. Fifth, popping or rumbling noises after flushing. If the noise continues after a thorough flush, you've got heavy scale buildup baked onto the bottom of the tank. At that point, regular flushing can manage it, but the damage to the glass lining may already be done. Keep up with maintenance and start budgeting for a replacement down the road. All right, here's that bonus tip I promised. If you want to essentially take anode rod maintenance off your plate forever, look into a powered anode rod. Unlike a traditional sacrificial rod that corrodes over time, a powered anode uses a small electrical current to protect the tank. The rod itself is made of titanium, which doesn't corrode. You install it the same way as a standard anode rod, same hex fitting, same location. The difference is you connect it to a standard electrical outlet and it sends a low voltage current through the water that prevents corrosion on the tank walls. The big advantage is it never needs to be replaced. A traditional rod might last 3 to 5 years depending on your water. A powered anode lasts the life of the tank. They typically run between $70 and $90, which is more than a standard rod, but you buy it once and you're done. They're especially worth it if you have hard water, well water, or that rotten egg odor problem. The titanium rod doesn't react with bacteria the way magnesium does, so it eliminates the smell without any chemical treatment. I've installed these on several jobs, and every single homeowner has been glad they spent the extra money. For the price of a decent dinner out, you're adding years to a tank that costs over $1,000 to replace. That's an easy trade. If this was useful, you will love the full book. 50 step-by-step plumbing fixes with diagrams, all in one guide. Link is below. Hit subscribe so you do not miss the next video. Thanks for watching.